Hey guys, don't know what happened there. Looked like the intro broke, but there we go. Could you type names in so I can do the register? So, Roddy so far. Becca, Alex, and Sophie. Cool. Anybody else out there yet? Joan. Cool. Right, while we wait for people, if you guys would like to get started on this one, it's a 7-mark vectors question. It has the stuff from last time. It's stuff from last week as well. Callum, hello. Right, so I'm going to start a timer so you guys can get started on this one. It says 7 minutes. Yeah, I'll give you guys, or 7 marks. I'll give you guys 7 minutes. Might need a bit longer. There's quite a lot to do. Maybe 8 minutes. There's quite a lot to do this one. Give that a go. Type names in when you do get here. Cheers, guys. Oh, and I'll start the Microsoft Teams chat as well, so you can send me answers. I think we'll just make that regular for everything now. Whenever you do a question, send me a picture of your answers on Teams so I can have a look through and see how you're doing. Right, guys. Cool. Still waiting for some of you. I've only got 1, 2, 3, 4, 5, 6, 7. Got 8 of you now, and it looks like have I made the stream private? I don't think so. I can't actually tell. I don't think it's private. Let's double check. Oh yeah, it's unlisted. What have I done? How have I done that? Okay, sorry. Yeah. Oops. Cool. Check your emails though, guys, because I always send a link, but yeah, I don't know why that's done. Ah, it's because I made that stream private the other day where I stole that video from YouTube. That would be why. That's right, guys. I'll just sign you in now. So we just did this as a starter, basically. Caleb, Fifi, cool. All right. So we got some answers posted there. Sophie and Becca. Right, so we'll go through it and then have a look at you guys. Your responses there. Phone's on loud. Cool. All right. So two complex numbers, and we want to first of all divide them. So the way we divide them is by using the complex conjugate. So we got 4 plus 6i divided by 1 plus I. The way we do that, times it by 1 minus I over 1 minus I. Similar to the way we rationalize denominators as we've seen before. And yeah, times that out. So on the top, we're going to get 4 minus 4 plus 6i minus 4i plus 6 over 1 plus 1. So that's going to give me 10 plus 2i over 2, which is 5 plus I for the first one there. Let's see what you guys got. So Becca, yep, good, and Sophie, brilliant. Okay. Okay, now we want to find the modulus of Z1 over Z2. So nice and easy. So today really is a bit of a summary lesson. So 5 squared plus 1 squared, square rooted, which is going to be root 26. That's what you guys got. Yep. And yep, excellent. And the argument of Z1 over Z2, so that's going to be 10 to the minus 1 of 1 over 5. And just to draw and check, I know it's an easy one, but we got, was it 5, 1. So it should be a positive, positive angle. So if we do arctan of 1/5, we get 0.197. Cool. Yeah, which rounds to 2 decimal places. 0.2. Good. So Becca and Sophie, brilliant job there. All right. Okay. Right, so yeah, the plan for today really is just practice everything we've done so far before it gets a bit more difficult next week. Some of the questions today are pretty horrible, and in some instances there's multiple ways of solving them. So I'm going to try and go through both ways. But yeah, it'd be good to see your workings today, guys, even if you're finding it difficult, just so I can see how people are getting on with the topic. So make sure you're all taking photos and putting them in the chat. Right, so I've written tricky here, so this one must be slightly trickier. How many marks? 3, 4, 5, 6, 7, 8, 9. I'll give you guys 10 minutes to do this one, although you might need a bit longer. See how you get on. When you've done ABCD or when you've made an attempt at ABCD photo, put it in the meeting chat so I can give you some feedback. So I'll give you 10 minutes starting from now. If you do need any help and you get stuck in the meantime, feel free to leave a comment and I'll give you a hint. So 10 minutes starting now. Cool. Right. So we've got a few replies: George, Becca, Roddy, and Fifi. Cool. How do you guys find it? No one asked for help. I thought you might need it, but it looks like you didn't. Yeah, looks like you all did right. Cool. Okie dokie. So find Z2. All right, let's do it. So Z1 divided by Z2 is 1 minus I. So we're going to say 3 plus 2pi divided by Z2 is 1 minus I. What's that, Joan? So if I rearrange this, I can do that little trick with my division, put the Z2 at the top, put the 1 minus I at the bottom, and then I've changed what the divisor is in this equation. So 3 plus 2p I divided by 1 minus I equals Z2. And then we've got a pretty straightforward division question. Let's try and see what Joan was chatting about. Yeah, cool. That looks good to me. So as you guys have done, we're going to times that. To do that division, we're going to do 3 plus 2pi over 1 minus I times by 1 plus I over 1 plus I to times by the complex conjugate as a fraction. Cool. So that's going to give me 3 plus 3i plus 2pi minus 2p over 1 plus 1. So 3 minus 2p over 2 plus 3 plus 2p over 2 I. So that's going to be my Z2. That's going to be my Z2. I guess I could divide that by 2. I don't know if we need to though. So that's the first 3 marks. Let me just have a quick look for you, see what you guys have done. So George, that looks good to me. I got 2p when I did it. I don't know if you've lost a factor of 2 there. I think you've copied it wrong there, George. I don't know if you can see that. It looks like you just missed out that 2. Becca. Yeah, that's the first bit I'm looking at there. Yeah, looks like you got the right idea there. Roddy, yep, simplified, but yeah, good. Fifi, yes, exactly the same thing I've got. Joan, yeah, you simplified it as well, that's fine. And Callum, yeah, I think that's good too. Right, so that's the first bit done. Given that the argument of Z2 is tan to minus 1 of 5. Okay, remember argument of Z is the angle. So given that the angle theta is tan to the minus 1 of 5, find the value of P. What this is telling me, if theta is tan to the minus 1 of 5, 5 must be y over x. So I'm going to divide my y and my x and call them. So remember, this is going to be the y bit, this is going to be the x bit. So that's going to give us 5 equals 3 plus 2p over 2 divided by 3 minus 2p over 2, like that. And we've just got a little equation to solve. So I'm going to times up by the bottom to get 15 minus 10p over 2 equals 3 plus 2p over 2. Times everything by 2, so we get 15 take 10p is 3 plus 2p. Rearrange it, we get 12 equals 12p, so therefore p equals 1. Okay, next bit we want to try and find the size of Z2. Looks like I've deleted Z2, so I'm just going to copy that back from one of your answers. Calendar's rotated weirdly. Let's take Fifi's one then. So I found P was 1, so I need to write out what Z2 is. So we got half plus 5 over 2i, I think. Yeah, cool. Right, what do I need? I want the modulus of Z2. Okay, so we just need to find the size of that. So that's going to be a half squared plus 5 over 2 squared. All square rooted. I'm going to do that on the calculator. Feeling lazy today. So the square root of 0.5 plus 2.5. Cool. So you get root 26 over 2. Nice. And last of all, draw them. Draw Z1, Z2, and Z1 over Z2. Well, Z1 over Z2 I've managed to delete. But I guess we could work it out again. Oh, it's 1 minus I. There we go. Cool. So, draw my Argand diagram. So we'll do Z2 first as it's right there. So we got half plus 5 over 2i. It's going to be there. Z1 was 3, what was PPP was 1, wasn't it? 3 plus 2i, so 3, and then 2, so it's going to be about there. So Z1, Z2, and Z1 over Z2 is 1 and minus 1. Left out my eyes there. That doesn't matter too much. So you should get something like that. I'm just going to check through the rest of your workings. They all look pretty good though. Georgette, even though you got that bit wrong earlier, your diagram looks right. And how did you get away with that then? Did you not miss a 2 out? I thought you did there. Okay, Rebecca, yeah, good. Rebecca, Roddy, you haven't got that far. Fifi, yeah, yours is good. Because the p-value doesn't change. Does it now? Oh yeah, it didn't have p in it. Fair enough. And last of all, Callum, your sketch is good. Yeah, nice. Well done, guys. Cool. So it wasn't that tricky after all. Yeah, have a look, George. I'm not sure what went on there. You definitely made a mistake in part A, but your sketch is right. So see if you can figure out what happened there. Yeah, if you need any help, let me know. Right, next one then. This one's a much bigger question and it involves a bit more kind of stuff. It shouldn't be too bad. It shouldn't be much worse than the last one was. So this is 11 marks worth, so I'll give you guys 11 minutes. And again, can you send me photos? If any of you haven't sent me any workings today, I'm just going to delete your attendance because, yeah. So can you all make sure that you're sending in photos of your workings? Some of you remained very quiet so far today, and some of you are working very hard. So well done those of you that are working hard. If you are not sending me stuff, I'm not going to believe that you're still here. So Yeah. Right, 11 minutes starts now. Cool, right, so some of you found B quite difficult. Alright, let's start working for it, and some of you done it though, let's yeah. Alright, we'll go through it, hopefully you guys will pick up what to do. So we want to find the exact value of the modulus of Z1 plus Z2. So do that, so Z1 plus Z2 is going to be 6 plus 6i, so therefore the modulus is going to be 36 plus 36. All square rooted, so the root of 72. Does that simplify? I reckon it probably will. So that goes to 6 root 2. That's the first one. Right, part B. W is Z1, Z3 over Z2. Okay. So we're going to times Z1 and Z3 together, divided by Z2. Right, let's see why this one was so difficult. Yeah. So Z1 times Z3, 4 plus 2i times by A plus BI. And then we're going to divide that by 2 plus 4i. I will check through your answers in a sec, guys. They might be horrible answers. We'll see what happens. So if I expand the top first of all, we'll worry about the division in a minute. 4a plus 2ai plus 4bi minus 2b. All over 2 plus 4a. So let's write that down again. 4a plus, let's do it in forms of 4a take 2b plus 2a plus 4b I over 2 plus 4i. So to do that division, we need to times it by 2 minus 4i over 2 minus 4i. Cool. It's not the nicest thing to expand, but it's definitely doable. So times each term by 2, and then times each term by 4i. So you're going to get 8a minus 16ai minus 4b plus 8bi plus 4ai plus 8bi minus 8ai. Oh, that'll be I squared, so that'll be plus 8a. And then, what will that last one be? Minus 16, so it's going to be plus 16b. All over 4 plus 16. Alright, so simplifying this one, simplify the top, so there's 2 8s there, so that's going to become 16a. What else we got? B's, that's those two down, I'll take them off. B's, we're going to have plus 12b. Minus 12ai plus 16bi. All over 20. So we need to write it in terms of real and imaginary parts. So the real part is going to be, I guess we should simplify it. So 16 over 20, so that's going to be 4 over 5a plus 3 over 5b minus 3 over 5. Let's factorize this a bit better actually. Plus 4/5 bi minus 3/5 of ai. So that's what I get for my w. But before I move on, I'm just going to check and see if that's in agreement with what you guys got, because I did a lot of work in there. Joan, yours looks half finished to me. Alex, yours looks pretty similar to mine, doesn't it? 4b minus 3. Yeah, cool. So I agree with those ones. Yeah, I'll assume that that's right then. We'll look through the rest of these in a minute. Okay, so given w is that, so we're going to set basically two simultaneous equations now. 4/5 of a plus 3/5 of b. Oops. 3/5 of b is 21 over 5. And 4/5 of b minus 3/5 of a is minus 22 over 5. So I need to solve both of these simultaneously. Cool, if I times everything by 5, all the 5s are going to disappear in both cases, which makes things a lot nicer to look at. And then if I don't know, we could times top 1 by 3 times the bottom 1 by 4, might be a nice idea. I'm going to get some big numbers. Yeah, I think that's probably the way I would go about this. So yeah, times the top 1 by, did I say 3? So we're going to get 12a plus 9b plus 60 equals 63. Times the bottom 1 by 4, 16b minus 12a equals minus 88. Add those together so the a's all cancel. So we're going to get 25b equals, what's that? Minus 63, make 88 minus 25. So b is minus 1. Put that back in, so we get 12a plus 9 is 63. So a should be 4.5. Who said we had horrible numbers? Those aren't exactly what I'd call horrible. And then find the argument of w. We can actually do this without needing a and b. So argument w is going to be tan to the minus 1, 22 over 5 over 21 over 5. We'll just sketch it as well. 21 over 5 there, minus 22 over 5. So it's going to be here. So my argument needs to be negative. So arctan of 22 over 5 divided by 21 over 5, which gives me 0.808. So my argument arg w minus 0.809. Oh, choose this one places A1. Cool, right, so have a quick look through your stuff. Do you lose marks for just putting simultaneous calculator? No, I think you'd be alright for that, because it's an assumed skill. Yeah, you'd be fine. Right, quite a few to work through here. Give me a sec, guys. I'm just going to look at your workings. Right, Alex, so yours look pretty good. I can't see your A and B though. You got A is 6 and B is -1. B is -1. I got A is 4.5. Have a quick look through, see who's right there. Sophie, what's going on with yours then? Because you got the same end. Sophie, what have you done? 4/3, 21 times 3. 28, yeah. Can't see what's gone wrong. Something's gone wrong there, though. George, what have you got? Again, weird numbers. Roddy, weird numbers. Fifi. Oh, you got 6 as well. Maybe I did do something wrong there. Lost my working there, though. Wrote W wrong. Charlie, we did C. I'm just going to check what A was, because I feel like I might have done something wrong on that bit. If 2 of you have got 6. Just rewinding a bit. So you had 4A plus 3B is 21. So 4A minus 3, 21, 4A equals 24. Yeah, A should be 6. Cool, but it doesn't change anything, but yeah, double check your A there. I'll just check it in the other equation. 4B, so minus 4. $18 divided by 3. Yeah, A is definitely 6. Double check that, guys. Cool. Hopefully that makes sense. Again, yeah, if you are making mistakes in simultaneous equations, you can always do it on the calculator. But yeah. Cool. All right. Hopefully that's okay. How long have we got? Half hour. I've got quite a few more I want to do. 3 more. Half hour. Oh, I think it's doable, but it's going to be tight. Let's see. If we can get through all these, I'll be really chuffed with how much work we've done today. So 5 minutes. This one shouldn't be too bad. I'll give you guys 5 minutes to do it. Again, take photos of your answers, post them in the chat. It's 5 minutes starting. All right, let's go through it. I had a couple answers sent there. Nice, yeah, got a few. Cool. So, complex number is that. Find the modulus of it. Nice, easy. We can sail through these now. So we've got 36 plus 9. So that's going to be root 45, which is 3 root 5. Cool. B, argument of z. So that's going to be tan to the minus 1 of 3 over 6, which is tan to the minus 1 over half, which I believe is 45 degrees, which will be pi by 6, is it? Let's check. Oh, it hasn't got, it's not exact. Okay, cool. 0.46, there we go. Radians to 2 decimal places. I think that was the 2 decimal places. If not, whatever. Okay, given the argument of lambda plus 5i plus w is pi by 4, find lambda. Okay, this is a bit trickier. So basically saying if the angle there, so theta is pi by 4, so tan of pi by 4 should equal y over x, so that's going to be 8i, oh sorry, 8 even, not I needed, 8 over 6 plus lambda. So if we do tan of pi by 4, we get 1, so 1 equals 8 over 6 plus lambda, therefore lambda equals 2. Alright, so have a quick look through your workings. I'll put the next one up maybe so we can kind of speed ahead. So this is 8 marks. I'll give you 8 minutes. I'll start a timer in a minute, but let's start looking through your workings. Now maybe I'll start the timer now. Be efficient then. So you guys start this. I'm going to look through your workings for that last one. See how you go. Yeah, really good work, you lot. Everybody got that spot on that's answered it. Don't forget to send me workings, guys, or you will not get attendance for today. So please check that out. Cool. All right. Let's go through it. So yeah, you do need. I would always advise sketching these. It just gives you anything you can sketch. Always gives you kind of an extra edge on the question. It's always worth a sketch. So find the modulus of z. So we need to do -1 squared plus minus root 3 squared. It's going to be 1 plus 3, which is going to be root it all as well. Root 4, which is going to be 2. Right, modulus of z over, so I'll put 2 there. Modulus of z over conjugate z. So that's going to be -1 minus I root 3 over -1 plus I root 3. And the way we're going to do that is by timesing by the conjugate of the bottom, which is just z again. So we're going to times that by -1 minus I root 3 over -1 minus I root 3. And this is a result that we're going to kind of learn probably next week, I think. There's a couple of results that we need to learn, but this is the first time I've seen this. So if you multiply this out, I'm going to get 1 plus 2I root 3 minus 3. So root 3 times root 3 is 3. I times I is -1. So we get negative there. And on the bottom, we're going to get 1. I think it's going to be 1 plus 3, is it? Yeah. So that gives me -2 plus 2 root 3 I all over 4. So -1/2 plus 1/2 root 3 I. And it wants the modulus of that as well. So I'm just going to write that down, I think at the top there. So cool. So the modulus of that is going to be 1/2 squared plus root 3 over 2 squared, which is going to be 1/4 plus 3 over 4, which is 1. Cool. Well, square root 1, but yeah, same thing. Okay, and the last bit for 3 marks, find the argument of each of these. We're running out of time. Argument of z then. So argument of z, that's going to be, if we sketch all 3. So z is -1 minus I root 3. There's z. Conjugate z is going to be -1 plus I root 3, so up here as you'd expect. And z over z, conjugate, is going to be -1/2 plus root 3 over 2. So it's exactly halfway up. So that would be z over z star, z star. Here we got z, which is an interesting one. So it looks like they're going to have the same argument there. No, we're totally running out of time. Okay, so argument z, that's going to be so tan to the -1 of minus root 3, or root 3 over 1. Then we're going to have to do tan to the -1 of root 3 over 2 over 1/2, and the halves cancel, which is why it's the same thing. And then tan to the -1, again, root 3 over 2. You know, the angle is going to be the same each time. It's just going to be positive or negative. So if we do that very quickly, tan to the -1 of root 3, we get pi by 3. So that's going to be this angle here. So our argument for z is going to be -2/3 pi. Arg for z star is 2/3 pi. Arg for z over z star is 2/3 pi. That's great. I'm going to put the next one up real quick. We might not finish it today, but at least it's up. So 4-mark question. Time is on now. I'm just going to look for your workings and I'll come back in a sec. I'll leave myself up. Why not? So you got basically to the end of the lecture to do this one. Let's have a look at what you guys have done then. Who was the first one to answer it? Becca. Well done, Becca. 2/3 minus 2/3. Yeah, nice. Good job there, Becca. Full marks for you. Sophie. Yeah, full marks for you as well. George. Your Argand diagrams could do some work, George, but your content is good. Perhaps we got Fifi. You guys could rotate it and save me the neck rotation, but you got a third pi. That's not the argument though. Remember, it's the argument mixed with the positive x. So yours you'd get most. You'd probably lose the last mark in each case, and you do need one of these to be negative. So check your signs there, Fifi, and make sure you're taking it away from pi because it's the angle measured from positive z rotating clockwise or negative anti-clockwise. And what else we got? Charlie. One of yours as well, Charlie, should be negative, but you wouldn't know that because you didn't sketch them. So make sure you are sketching them always. And Callum. Oh, that's the okay. Sorry, Fifi. Callum's good. Let me check Fifi's again. Oh, sorry. Yeah, yours are up. Okay, yeah, cool. Yeah, fine. Didn't see it. Your workings. Make your workings clearer though, because as an examiner, I might have missed that. So, yeah. Right. See how you go. And if anyone finishes this, we will go through it. No, maybe we won't. I think this. Yeah, I wanted to spend some time on this one. There's 2 ways you can do this. There's a kind of a geometric way where you draw some triangles. So there's drawing triangles. And then there's the algebraic way. And the drawing triangles is easy, it's worth 4 marks. The algebraic way is an absolute pig to do. I did it yesterday and it was nasty, real nasty. So I want you guys to try this, but also give the algebraic way a go. There's a challenge there. If anyone can do the algebraic way, then I will be impressed. It's that one. Because it's a lot of manipulation of algebra, rearranging stuff, and vectors as well. Okay, while you guys are doing this, I just need to update you. The assignments need to be done again because we're doing new content. I should have set you the first one last week, but I completely forgot. So we are a week behind on assignments, which means you're either going to have to do 2 one of these weeks, or you're going to have an extra one to do over the summer. I'll probably just leave it for an extra one over the summer. If you guys go on Moodle, you can see assignment 1.34 is there. That needs to be done for next Thursday. And we will also be doing skills checks as well. If I set that for next Thursday, I might set 1.35 for the following Tuesday, and then 1.36 for the following Thursday. Because I'd like to get caught up and be finished by summer holidays. So if you guys could start 1.34 or do 1.34, start 1.35 as well, and we'll get caught up on those assignments. Yeah, cool. And then there will be some skills checks too. But they're all on Moodle now. The solutions will be going up quite soon for 1.34. But if you guys can work your way through those, that'd be brilliant. Cool, right, we'll save 12 as a starter for Monday's lesson. So. because I'd like to have an attempt at the algebraic, or see if anyone's done the algebraic method. Cool. All right. Have a nice weekend, guys, and see you next week. If there's no questions, then I'll end the stream. If there are questions, ask them. Cool. All right. Cheers, guys.